For today's lesson, we will be discussing about propositions. So we will define first what is a proposition, and then we will be discussing as well the simple and compound propositions, and we will be discussing also the different kinds of compound propositions. So let's define first what is a proposition. So a proposition is a declarative sentence that can be classified as either true or false, but not both. So when we say proposition, again, it is a declarative sentence that is either true or false only, but not both. So if the sentence is, let's say, in question form, if it's interrogative, or if it is imperative, then that is not considered as a proposition. Thus, a proposition has exactly one truth value. So we can only say if it's true or false. So true, which we denote by T, and false, which we denote by F. Here are just some examples of propositions. So first one, if today is Monday, then tomorrow is Tuesday. So this one is an example of a proposition because it can be answered by a true or false, and its truth value is true, or T. Second example, a trapezoid is a parallelogram. So again, this is an example of a proposition, and its truth value is false because before you can say that a quadrilateral is a parallelogram, it should have at least two parallel sides. And then last, we have 5 plus 2 equals 10. This one is also a proposition. So this is a mathematical sentence, and its truth value is false because, of course, obviously, if we add 2 and 5, the answer is 8, not 10. Now, there are two kinds of propositions. First is the simple proposition, and then we have the compound proposition. Simple proposition, it conveys one thought with no connecting words. Whereas if we have compound proposition, it contains two or more simple propositions connected by connectives. So what are the connectives that we are using? So we can have and, or, if then, if and only if, and any other forms. Now, if there is only one thought and then there is no connecting words, we call it as a simple proposition. However, if there are now two or more simple propositions combined or connected by the so-called connectives such as and, if and only if then, and or, then we will call it as compound proposition. Now, here are just some examples of simple and compound proposition. So for simple proposition, we have the sky is blue. The measure of a right angle is 90 degrees. For compound proposition, we have the angle measured is 90 degrees if and only if it is a right angle. You will see here that the connective that was used is if and only if. And then the two propositions, we have angle measures 90 degrees and it is a right angle. Another example, if today is Tuesday, then tomorrow is Wednesday. So this is another example of a compound proposition. This one, the connective that we use is if then, and then the two propositions that we have is today is Tuesday and then tomorrow is Wednesday. Now, there are different kinds of compound proposition. We have the conjunction, disjunction, conditional, and biconditional. So let's discuss them one by one. For conjunction, a conjunction consists of two simple propositions connected by and. So the kind of proposition depends on the connective that we used in the sentence. So again, if we use and then there are two simple propositions, we call it conjunction. And this is the symbol that we use for conjunction. So we use it's like a V or an inverted V. So that is the symbol for conjunction, for and. Now, A and B, these are the two simple propositions. So in logic, we represent propositions as letters. And then we write them into its propositional form using, again, the letters that we assign to each proposition. So, example, we have proposition 1. 7 is a prime number. We also have another proposition, 3 is an odd number. Now, if we will put them together using the conjunction, we will put and here. Therefore, it will now become 7 is a prime number and 3 is an odd number. So this is A, our first proposition, and then this is B, which is our second proposition. So if you will write this in symbol, A is a prime number and B is an odd number. For this junction, it consists of two simple propositions, but this time it is connected by OR. So it is expressed as A or B. So it's something like this. So this time the symbol that we're using is like letter V. A and B again here are the simple propositions. We just represent them using letters. So let's have the same example here. Proposition 1, 7 is a prime number. Proposition 2, 3 is an odd number. If we will connect this using this junction, so it will be 7 is a prime number or 3 is an odd number. So we use here OR as our connective. So A again is for the first proposition, B is the second. So we have here 7 is a prime number or 3 is an odd number. So we can use any other letters. Sometimes we use P and Q and then M. So it depends on you. Next is we have conditional statement. So a conditional statement consists of two simple propositions that are connected using the connective if-then. So this time we are going to use the if-then. And the if part of the statement is what we call as the antecedent, and the then part is what we call as the consequent. So we express it as like this. So if A, then B. So the symbol that we're using for conditional statement is an arrow like this. Conditional statements can also be referred as implication. So just take note of that. Here's an example. Let's say the implication here is if today is Tuesday, then tomorrow is Wednesday. Now the if part of this implication is what we call as the antecedent. So that is today is Tuesday. And then the then part of it is for our consequent, which is tomorrow is Wednesday. So if we assign letters to this, so we can say that this is A, this is B, and if we write this into its propositional form or symbol or in symbols, then we can write it as A, if A, then B. Instead of writing the conditional statement into its if-then form, we can also use the word implies. So it can also be written as today is Tuesday implies that tomorrow is Wednesday. So we are still talking about the same thing here. So just a few things to remember. And last is we have biconditional. A biconditional statement is a conjunction of two implications formed by exchanging their antecedents and consequents. So here we have two implications and we connect them using conjunction, so using and. So all we have to do is just to interchange the antecedent and their consequent. So let's have this example right here. So let's say we have this implication 1. So the first implication, if x equals 1, then x plus 1 equals 2. For the second implication, notice that the consequent of the first implication is now the antecedent of the second one, and the antecedent of the first implication is the consequent of our implication number 2. If that happens, then we can connect the two using a conjunction and we will create now a biconditional statement. So if x is equal 1, then x plus 1 equals 2. And if x plus 1 equals 2, then x equals 1. Now if we want to write this in symbols, so of course we have to represent it using letters. So the first one, this if statement here, let's use A, x equals 1. And then for x plus 1 equals 2, let's denote it using B. Now following this sentence right here, if x is equal to 1, so if x is equal to 1, which is denoted by A, then, so we use an arrow, x plus 1 equals 2, then B. So if A, then B. Then we just close it using a parenthesis. And then we have this word and. So and we use an inverted V, so something like this. Then let's write the second implication. So if x plus 1 equals 2, so that is B. Then x equals 1. Then A. Now, if you notice, there are repeated if and then words here. So, to remove the redundancy in this biconditional proposition, we can just use if and only if. Okay? So, it can also be written as x equals 1 if and only if x plus 1 is equal to 2. Now, to write this biconditional statement using the if and only if, so we just consider this as A again, and then this one is B. And then we have x equals 1 if and only if. So for if and only if, we use arrows, or it's like a line, a two-way arrow, and then x plus 1 equals 2, or B. So A if and only if B. So that is how we write biconditional statements or propositions. We also have what we call as negation. So a negation is a simple proposition that denies the truth of the given proposition. That is, the negation statement is false whenever the given statement is true, and true whenever the given statement is false. So that means we are just getting, from the name itself, we are just getting the opposite truth value of the original simple proposition. So an example would be, let's say the proposition is the sky is blue. If we will get the negation of that, then that will be the sky is not blue. So how will you know if it's a negation? If it is a negation, if you see some words that denotes negation or negative, for example, not is not, do not. So those are examples of words that we can use to denote negation of the said proposition. So how are we going to write it in symbol? So let's say P is our proposition, the sky is blue. Now if we want to write it into its negation form, then it will be like this. So there's just a wave in front and then P, which is read as not P. So sometimes this is the symbol that we're using, or if you will see somewhere, they use like this one, but they denote the same thing, which is negation. Now I will just show you some examples of sentences, and let's try to identify if it's a proposition or not. And if it's a proposition, let's further determine if it's simple or compound. Elephants can fly. So as you can see, this one is a declarative sentence. So as you can see, this one is a declarative sentence, and it's answerable by true or false. So we can say that this is a proposition, and since there's no connective used, then it is a simple proposition. Are you and mom coming to the game tonight? Now, looking at the structure of the given statement or sentence, this is in question form, then automatically we can say that this is not a proposition. Okay, so based on the definition of proposition, it should be a declarative sentence. So again, this is not a proposition. If x equals 3, then 2 is less than x. So this one is a declarative statement or sentence. And as you can see, we have their connectives if then. And from the statement or from the sentence, we can see two simple propositions. We have x equals 3, we have 2 less than x. Therefore, we can say that this one is a compound proposition. Again, the connective used here is the if and then. Her dress is blue and her blouse is red. So this one is declarative. And there is now here a connective and then let's check. After determining the connective, let's now check for simple proposition. So we have here her dress is blue. This is a simple proposition. We also have her blouse is red, which is another simple proposition. Since there are two simple propositions and they are connected with a connective and, then we can say that this one is a compound proposition. Next, the number 2, 4, and 1000 are even numbers. Now you might say, maybe this is a compound proposition because there's and. And you might think because there is an and in the given statement or sentence, then it is automatically for conjunction or under conjunction. But you have to analyze what is the purpose of and. Does it connect two simple propositions, or it is just used to connect subjects of the given sentence? So let's read again. The numbers 2, 4, and 1000 are even numbers. If you notice, if we will separate the two, the numbers 2, 4. So that is not a complete thought. 1000 are even numbers. Also, not a complete thought. So that means this sentence here conveys one single thought, which is the numbers 2, 4, and 1000 are even numbers. And the end here is just used to connect the subjects, not to connect two simple propositions. So this one is a simple proposition only. Now this time, what we will do is, let's try to classify if it's simple or compound. And if it's a compound, let's classify it even more as conjunction, disjunction, implication, or biconditional. And then after that, let us express the proposition into its propositional form with P as the first statement and Q as the second statement. If a polygon is a pentagon, then it has 5 sides. Then if a polygon has 5 sides, then it is a pentagon. If you will look at the given sentence, you will see that there are two implications. If a polygon is a pentagon, then it has 5 sides. So that is the first implication. The second one is that if a polygon has 5 sides, then it is a pentagon. So there are two implications and they are connected by the connective and. So we can say that this one is biconditional. Now, how are we going to write this into its propositional form or in symbols? So let's assign letters for our simple propositions. So we have here a polygon is a pentagon. So let's write P for that. Then it has 5 sides, or polygon has 5 sides, can be our Q. So let's write here Q. So if you will write it into symbols, if a polygon is a pentagon, so you have P, then, so let's use the symbol for implication, then it has 5 sides, then Q. Close it in a parenthesis. Then for end, we use the inverted V. If a polygon has 5 sides, so that is Q. So if Q, then it is a pentagon. So polygon is a pentagon, so we have P. So this is now the propositional form of the given statement using the variables or the letters P and Q. Next, you are in a band and you play the drums. So in this one, the only connective that we see is and. So that means this one is for conjunction. And then let's write them, or let's write this into its propositional form. So let's assign letters for our simple propositions. You are in a band, so this one is P. And then you play the drums, so this one is our Q. So you are in a band, P, and so let's use the inverted V. You play the drums, so Q. So this is now the propositional form of our given statement. If it is not raining, then I will not bring an umbrella. So in this case, you see we have if and then as the connectives. So that means this is an implication or a conditional statement. Now let's assign letters for each of our simple proposition. So we have here it is not raining. So let's write P, and then I will not bring an umbrella. So this one is Q. But notice that in our statements, on our simple propositions, they have the word not. And that word not denotes that the given statement is in its negation form. So what we will do is, instead of just writing P, we write here not P. And then for Q, since again there is a word not, we have to write here not Q. That means the statements given in this problem or in this statement is in its negation form. So to write this into symbols or propositional form, if it is not raining, so if it is not raining, then I will not bring an umbrella. So there. So this is now the propositional form. If not P, then not Q. And lastly, x equals 3 or x is equal to 2 plus 1. So as you can see, there are two simple propositions, x equals 3. We also have x equals 2 plus 1. And then there is the connective or. So this one is under disjunction. So let's denote this as P, and then let's denote this as Q. Okay, so to write this into its propositional form, so we have P or, so we have to just write a symbol like that is the same as V and then Q. So P equals 3 or x equals 2 plus 1. So this is now the symbol or the propositional form of the given statement. So that's it for today. I hope you learned something about propositions. What's the difference between simple and compound proposition, as well as the different kinds of compound propositions, and see you next time.